Welcome friend, welcome to my tutorial, actually 7th tutorial. In this tutorial I will be explaining about the integration of function by using trapezoidal rule. Okay, so we will integrate f of x on the interval a to b using trapezoidal rule. Actually I have taken this formula from the Wikipedia, but trust me, this is the right formula as I have here as well. But okay, to be more clear, it is better to see this formula from the Wikipedia. Alright, so trapezoidal rule is nothing but the integration of f of x dx at the interval a to b, and this is equal to this. Alright, so first what we do is we divide this interval a to b, a and b into various subintervals, into n subintervals, and we assume that interval, within that interval we find a trapezoid over here. See, we simply assume this function to be linear within this interval. So this is linear and this forms a trapezoid. So finding area of all the trapezoids and summing those, we will get the answer of the integration. Alright, so from this mechanism this formula can be obtained. Okay, in this formula this delta x is nothing but the interval of sub interval. So distance from xi to xi plus 1, that is distance between any two consecutive interval is nothing but delta x. Okay, so in my formula I will be denoted this delta x by x on my formula. So this is our formula. So the initial point, functional value at initial point and functional value at the final point is added without multiplied by 2, but the rest of the points are functional value at the rest of point are calculated and multiplied by 2, and then sum is done during the integration. Okay, so this delta x is of course final point minus initial point divided by how many number of subintervals you want to make, then that would be the width of the subinterval, and if you cross multiply it, then okay, position of ith subinterval would be initial value plus I into width, that is x. Okay, so in here x1 equals a plus x1 into x. Similarly here x2 equals a plus 2x, x3 equals a plus 3x, etc. So sum is done from x equals 1 to n minus 1 and multiplied by 2. Alright, so in Fortran code I will differentiate this. See, f of x naught, f of xn, and then rest as the sum. Okay, so now let us move to our code in the Fortran. To do that, let me open terminal, Control Alt plus T, and this is, where is that? Alright, so battery is low. Wait a minute, I'm gonna add this, insert charger of. Okay, so this is my terminal. Now let me open editor, gedit, and name of it is trapezoidal.f90, and this is what I opened. Alright, so program and end. This is the format of the program. Name of the program would be trapezoidal. Alright, so let me define the function to which I need to find the answer of integration. Right, let me find some examples from where I can simply do integration. Alright, so solve example, maybe, yes, that should be over here within this PDF. Alright, so yes, this PDF gives a detailed introduction of the theory. He has also the interval a and b is divided into nth interval. So from starting from x naught, that is from a to xn, that is up to b. Okay, so within this interval a trapezoid is formed. So we will find the area of each trapezoid and then add up all the area of the trapezoid, and finally we get the answer. So at those points where the function is exactly not linear, that will form some error over here. See, you can simply say this: we will have more integrational value on this point, which is error. Similarly, less integration value on this point. Alright, okay, I already said about this formula, so let us take one example. Okay, this is our formula, this is our function. Root under 1 plus x square is our function. We want to integrate this between 1 to 5. Okay, so let us write that in our okay, let me define function first. Real function name is of course x, and this is the format of the function. Now function is, root under is sqrt, this is root, and inside root we have 1 plus x squared. Okay, so this is our function. We can define this in by another way as well. Simply f equals bracket 1 plus x square to the power is simply double asterisk, half is nothing but 0.5. okay, so this is also 1 plus x square whole root under. Okay, this and this is same. We can use either this or this one. Alright, this is our function. Now what we do is we need to give the limits of integration. Simply see, this is the limit of integration. Lower limit is a equals 1 and upper limit is 5 equals b. So first give lower and upper limit. First of all, let us decorate this program. Welcome to this program. This program do integration does, my English is really poor. This program does integration using trapezoidal rule. Okay, so this will be printed on the screen. Now we need to give what? Lower limit. Please insert the limit of integration. Okay, so computer need to read this. To do that, you already know this, read should be inserted. So lower limit is nothing but a, so I have used a. First write implicit, okay, sorry, implicit, none. Okay, so this a may be anything, so I am defining this as real variable. Alright, so this is lower limit of integration. Again we need to have upper limit of integration as b, so let us say please insert upper integration. Okay, so it should be read as b by the computer, right? So this is a and b. Now we want to divide this a and b into different sub intervals. Alright, different sub intervals. So we don't know how many sub intervals we want to define. So please insert number of sub intervals. Insert of sub interval. Make sure that to to have the right answer, you need to have number of sub interval as large as possible, because for a very large value of n, that is for very small value of width, the function can be assumed to be linear. Otherwise it may contain some error. So use large value of n as much as possible and use value of yachts as least as possible, where yachts is nothing but the width of the subinterval, right? So print, please insert the number of subinterval. Computer should read this as n, but this n is integer, not real number, so define it by integer. Alright, so we defined n. Now computer will itself find width of the subinterval. So yachts would be equal to, yes, you already know that, from this formula. Okay, that may be in here. This is yachts and this yachts is b minus a over n. Okay, so yes, write down b minus a over yachts, sorry, n. Alright, so this is our yachts, width of the subinterval, but I have not defined yachts, whether it's real or integer. This may be real, must be real. Okay, so computer found yachts. We already defined function. To call this function inside our program, we have not inserted real external, so name is nothing but function yaf. Alright, and now this is yachts, and simply you can see formula from here. I already mentioned that I will separate yaf of x naught, yaf of action in one formula and the rest of these sums in the another formula. So first let me define a number called p as real number, right? So p is nothing but, you will understand it later, p equals yachts over 2, and okay, so this is yachts over 2 into f of a plus f of b. Alright, I need to close this. Okay, this is p. See, and on this formula I included f of x naught, f of xn, including yachts over 2. Now rest should be from here to here, including yachts over 2. Alright, and finally adding all, we can get simply answer. Alright, so this is p. I have defined p over here as real parameter. Now to do sum, we need to define sum equals 0 for our initial, and we will do I equals 1 to n. Alright, to do sum we need to use do loop, int do. This is the format of do loop. Okay, so this will have sum equals, simply what is the formula, yachts over 2, yachts over 2, and this 2 will be cancelled, so yachts into this sum of all those things. Alright, simply we can write sum equals yachts into okay, so yaf of a plus I into yachts. Okay, so this is our yachts, where I runs from, you can simply see I runs from 1 to n minus 1. Oops, so this is not correct, use n minus 1 here. Alright, so I will explain about this figure, sorry, about this. So first of all, for I equals 1, okay, sorry, wait, this is our formula. For I equals 1, sum equals 0 will be used here. So for I equals 1, sum would be yachts into f of a plus yachts. Okay, that is x1, f of x1. For the now that is sum 1. Okay, again for I equals 2, this would be the sum 1 and this would be the sum 2. So again I would be 2, a plus 2s is f of x2 into yachts, and it is added with sum 1, and you will have sum from I equals 1 to 2. Again in I equals 3, this would be the sum 2, this would be sum 3. Here f of a plus 3 yachts would be f of x3. In this way, up to n minus 1, the functional value multiplied by yachts is added, and you will get the rest of this. Alright, okay, rest of this when added with f of x0 plus f of xn, you will get the integration. Alright, so this is sum, and finally we will have integration using trapezoidal. Integration value is equal to what? This plus this. Alright, sum plus this, so p plus sum. Alright, so this is our value of integration. Simply say again, f of x0 plus f of xn into s divided by 2 is p, and this is rest is sum, so sum plus p gives the integration. Okay, so this is what I am doing. Alright, but I have not defined integration, whether this is real or integer. You know, this may be real as well as integer, so this may not be integer always, so I should define this as integration. Alright, this is how one can finish the program. To show this result on our screen, you know what we need to do. The value using rule is, this will be displayed on the screen and answer will be displayed. Alright, so this is our program, and this is really an easy one. Okay, so these are the input codes. Only these are the codes for calculating, and this is code for showing that calculated result on the screen. Alright, let me save it by Ctrl S, and then let me show whether I did some error or not. Okay, simply compile this trapezoidal.f90, and okay, symbol I has no implicit. I have not defined I over here. See, I is integer as you know, but I have not defined, so define it. Ctrl S is saved, and again compile this. Alright, so again sum is not defined. Yes, I forgot to define it. Sum is the real number, so define this, and again Ctrl save. Yes, is save, and compile this. Again integration equals integration, sorry, spelling is wrong here. Integration is right, integration is right, but here integration, sorry, no, this is fine. Saved and compiled. Alright, yes, now we are right. Okay, so yes, compiled to say it as our output. Welcome to this program. This program does integration using Simpson rule. Please insert the lower limit of integration as previously I said. Sorry, this is our example. Lower limit is 1, upper limit is 5. Okay, so insert 1 as a lower integration, 5 as our upper. Number of sub interval. First of all, let me divide it into 10 sub interval, and then the answer would be 12.75. okay, so in 10 sub interval I found answer as this. And now again let me use another. In lower limit is 1, upper limit is 5. Sub interval, let me see it as 100 sub interval. Then see answer difference: 12.7596016 75601. So it is correct up to the second decimal places but not correct to the rest. Okay, so again we are increasing the number of sub interval and its value is decreasing. Again let us check another value of yan. Lower limit is 1, upper limit is 5, and sub interval is, okay, let me write it as 1000. Then you can simply see answer is 12.7559. see here 60 again. This is right only up to the second decimal places. Let us check whether what's the answer. Okay, so the answer is 12.76. I'm sorry to say that this question has given only answer up to the second decimal places. We have already found the correct answer just from the 10 sub interval as, oh no, sorry, while dividing the function into interval into 10 sub interval, answer is not absolutely correct. 12.76 is not here. 12.7575. so this is the round of answer as here approximately. Alright, so again let us find this as our question. Function is y only, and what is that y? Following okay, we have not defined y over here like this, as y should be function of x. Let me define that y as same but interval change 2.1 to 3.6. then what we get as our answer: 2.1 as lower limit, 3.6 as our upper limit, and number of sub interval as 10, and answer is 4.53. What is the answer? 5.22. see, while dividing this function this interval into 10 sub interval, then we are not having the right answer. Let us divide further. 2.1, 3.6, and number of sub interval is 1000, and answer is 4.53. So maybe this function is quite different than this, so we can verify this result by using another example. Let me see the example. Okay, we can find some example in here. Okay, do we have answer of that? Oh, again same, sorry. Yes, we do have sin x. We need to change the code, so I'm not interested on doing this, on verifying the result from this example. Do we have any other examples? Okay, examples are here. Alright, do we have function? Yes, x3 and interval is 1 to 2. Okay, let me change the code. First, function is x3, not this one. Okay, x to the power 3. Alright, no, we can delete this because this is not required here. Save it, and then compile it. Okay, now it's compiled. Let us check the output. We don't know what is the lower and upper limit, 1 and 2. Alright, 1 to 2, then lower limit is 1 and upper limit is 2. Let us divide this into 10 sub interval. Answer is 3.75. What is the true answer? 79. Okay, this has divided into 4 sub interval, but I have divided into 10 sub interval. Let me check this. dividing into 4 sub interval, 1 to 2, and sub interval is 4. Then answer is 3.79, which you can simply check from here. Okay, 3.79 something something. So this method gives the accurate answer only if the number of sub interval is increased. So less number of sub interval, less accurate your results. So use sub interval as small as possible and number as large as possible. So, and finally I would like to say that each method is not free from errors, so this method also contains some sort of errors. So I would like to explain those errors in my next upcoming video. Thank you so much for watching this video. Please do say something about this video and about this tutorial. Thank you.